confirm this 0.049 p-value with the bootstrapping utility, which does not assume normally distributed data. So let's look at that. Correlate, bivariate, and then click on this button here, Bootstrap. Performing Bootstrap, 1000 I think is the default, and I would keep it at that. There's not really much benefit to increasing it beyond 1000. And then click on Bias Corrected Accelerated. Research suggests that the bias corrected version is better. There's not a huge difference between the percentile method and the bias corrected, but I would use the bias corrected. And 1000 resamples. Again, I'm not going to explain what bootstrapping is. The only thing I'll say is that the utility is going to resample from the existing data 1000 times. There'll be 1000 samples upon which it's going to calculate a correlation, and it draws those samples from the existing sample of 50 people. It's resampling with replacement. For each case that's sampled, it's then put back into the parent sample, and then another case is sampled. Again, I'll explain this in another video. So will this Bootstrap utility help corroborate the first correlation p-value? It's going to produce the same exact correlation, but will it give the same p-value? And SPSS has done the analysis. It hasn't taken very much time, so 1000 resamples, in a blink of an eye, basically, with a sample size of 50. It does take longer when you have a sample size of 1000 or something like that, 500. It will take more time. Still not a lot of time if your computer is fairly fast. So here's the correlation of 0.28 that we obtained in the previous analysis, and here's that p-value again. Now this isn't the Bootstrap p-value. This is the p-value from asymptotic normal distribution theory, the regular p-value. Now what SPSS outputs with respect to the Bootstrap results are confidence intervals, and they're 95% confidence intervals, so they correspond to an alpha of 0.05, if you will. And what we would expect if there was a statistically significant result, p less than 0.05, we would expect that the lower and upper bounds of the correlation would be on the same side of either positive or negative, depending on the point estimate of the correlation. In this case here, the point estimate is 0.280. So if the bootstrapping technique is going to corroborate the p equal 0.049, both the lower bound correlation and the upper bound correlation have to be positive, and they are not. The lower bound correlation is negative 0.196, and the upper bound is 0.721. So this is suggesting that based on the bootstrap estimation technique, there is not a statistically significant correlation between variable 1 and variable 2, both of which are substantially skewed. And I would trust this bootstrap result more than I would trust this p-value here. And that's because this estimation technique does not assume normally distributed data. Now you don't get a p-value from SPSS to report, so it would be something like 0.0, maybe 0.065 or something like that if a p-value were estimated. Unfortunately, SPSS doesn't give it to you. It just gives you the confidence intervals, which is very good in its own. You can use a program like AMOS to get the p-value. Maybe I'll show that in a future video. But in this case here, it gives you the confidence intervals, which is very good. So this is really all you get. That's the additional information from a bootstrap analysis. Very useful if you have non-normally distributed data. Now what I'm going to do in this second bit is I'm going to do the analysis based on normally distributed data to see if the p-value from asymptotic normal distribution theory is the same as the bootstrap p-value. And I've simulated these data to be very similar to the first lot. The only difference is that they're not skewed. And I showed that earlier in the video over here. These two variables here are the ones I'm going to correlate now. Now they're going to have the same exact correlation of 0.28, but I'm going to bootstrap the p-values or the confidence intervals respectively. Alright, bootstrap is selected and click OK. And here are my results. And we can see that the correlation between the normally distributed variables is 0.28, and the asymptotic distribution theory